Well, hey everybody, as we start to progress here, we are getting ready to start chapter 6, which is still dealing with linear. Everything linear, 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 linear. Bunches of lines, only now we're dealing with two lines at the same time. So it's called a system of equations, and we're going to have to start to solve systems. Well, first thing is that if somebody classifies something to be a system, clearly there is some sort of relationship that happens between the two different variables in each of these. And at some point, we have a solution to a system. And so we can start to see our first set in this entire chapter is going to be about graphing the system. So we can visually see what's happening here. So when two lines are considered to be a system, they have points in common. So what this means is that the same input into each equation is going to produce the exact same output. It's like one number gives you the same answer for both of the equations. This means that that is the point where the two lines actually intersect, or they actually cross. So that's what we have to look at and think about and be careful. We're going to be looking at graphs, and we're going to start to look and say, hey, at what point do these two graphs intersect each other? That point is the solution to the system of equations. And in fact, it's two specific numbers. You're getting two answers that can be represented as an ordered pair. So let's look at example 1. Look at example 1. So in example 1, we have this line here and this line here. And if you look, they want to know what is the solution to this system of equations. Well, I can see this, right? Right there at that point, this point right here. This is the point, the one and only point where these two lines touch. They intersect. They share the exact same point. They share the exact input and the same output. So if you were to plug the x coordinate here is what? 2. Whatever the equation is for the first line, if you were to plug 2 in, you would get 0. The output, the y coordinate. Same thing on this equation. Whatever the equation for this line is, when you plugged in a 2, your output would be a 0. So therefore, these are the solutions to this systems of equation. It's the when x is equal to 2 and y is equal to 0. Together, that is a ordered pair. It is the ordered pair 0, 2. So again, not so bad. Again, graphs are our friends. They're literally cheat sheets of all the possible answers. Now, let's look at this one. This is a graph that we haven't technically learned how to graph yet, a quadratic, but it is still considered to be, this is a system of equations, system of nonlinear equations, because one is not linear, this one is. The U shape is quadratic. But I can, just looking at this, I can tell right here and right here are 2 points where these lines intersect. All right, -1, 1. Here's one solution. Here you have what? 1. We'll say that's 2. Yeah, track it back. Yeah, it looks pretty good, right? 1, 2. 1, 2. Those are my solutions to that system of equations. It's simply the point where the two lines intersect. As we move down, what happens though? They gave us the lines here. They're going to give us equations that we have to actually graph, and we have to find the system, the solution to the system. So here is a system here, y equals -1/2 x minus 1, y equals 1/4 x minus 4. We have to graph each one. Let's start off with the first one, our b. So remember, y equals mx plus b. B is the y-intercept. It's the place that we want to start graphing. So on our y-axis, we want to go to -1 and put a dot. And then our slope is negative 1/2. Negative 1/2 means I'm going to go down 1. I'm going to go over 2. And here's my second line. Go down 1 over 2. Go up to the left 2. Up to the left 2. Notice how I'm creating this line here. Just trying to draw it as best as I can with a mouse. Great. Now we have to graph the next equation. This one has been graphed for us. Well, we're starting at an x or a y-intercept here of -4. Put a dot at -4. And our slope is 1/4, positive 1/4. So I'm going to go up 1 and to the right. 1, 2, 3, 4. And this line is right through here. You can see this, you could tell it. I did not draw this exact right here. Let's see if I can get that one better. So now we should be able to see that this section right here, that's the point where these two lines intersect. What is the solution to this systems of equations? Well, it is the coordinate, or there's two solutions technically, an x and a y. It would be 4, -3. And now we go to graph the next one. All right, here we go. This one is in that slope-intercept form. It's ready to go. My y-intercept is a 2. I put a dot right there. My slope is -1/2. Means I go down 1 to the right 2. Down 1 to the right 2. And reverse it. Up 1 to the left 2. Up 1 to the left 2. And I'm going to try to connect. All right, that's a much better line there. And uh-oh, this is an issue here. This isn't in slope-intercept form. So if we remember from our section, last chapter, section 5.5, we are able to take this. If we want to solve for y. That will put this equation into slope-intercept form for us, and then we can easily graph it. Imagine all this stuff that we learned from before starting to be seen over and over again. I'm trying to solve for this variable that's stuck in this term. I need to add 3x to both sides. I'm going to rewrite it. 2y is equal to, 3x and 4 are not like terms. Y is not by itself. Divide each piece by 2. And I reduce. So y is equal to 3 over 2x plus 4 divided by 2 is 2. Here's my intercept. Right here at 2 again. I'm going to go up 1, 2, 3 over 1, 2. And like that, I have a second line. And we can see again, look, right, where do they intersect? They intersect right here at this point. That particular coordinate is the coordinate 0, because it didn't move left or right, and up 2. So, two solutions. This one's larger. Two solutions. Two solutions. The solutions together form an ordered pair. So it works. So we have to make sure our skills from graphing are good. Now we need to see the next couple examples are going to be asking us, well, how many solutions do we actually have? Look at this. What's going on with this? We have two lines that are parallel. Two parallel lines. Here's a system. Do parallel lines ever touch each other? Hopefully not, right? Think of an interstate going down like 95 all the way from, what is it, South Florida all the way up to Maine. Hopefully, north and southbound lanes are parallel the whole way, so they never intersect. We got some issues, right? They never intersect, so this is no solution. There's no solution to this. They never touch, so if they never touch, then you'll never have a point in common. Well, look at these two lines. We have a line here, we have a line here. Clearly, I can identify one individual point. This one point here. So this is one solution. And how would we look at this? Each line has a different slope. So if we needed to identify why is there only one solution, it would be that each point or each line has a different slope. And if they gave you two equations, you make sure it's in slope-intercept form, look at them. Do they have the same slopes or different slopes? We want to go back and look at this one here too, right? Why is this, if we had to put this into words, why is this has no solution? So they have what? The same slope with different or y-intercepts. That would be why there's no solution to it. Look at the last one. Wow, this is interesting. I've got two lines. They've even given me some equations this time. Let's go to this. But this is really weird, right? First off, this is not in slope-intercept form. We need to simplify this, right? We could what? Divide by 2, divide by 2. I'll reduce. Then we have y equals x, question mark. Notice that these are the same line. They're the same. When you reduce it, it ends up being the same, and they sit on top of each other. So these would have actually what? If they touch everywhere, this is an infinite solutions. Infinite solutions right here. And why? If we had to put it into words, why is it an infinite solution? They have the same slope and the same b, which is the y-intercept. Notice, same slope, same y-intercept. There you go. And that is, in a nutshell, that is how we visually can inspect a system of equations and determine what is the solution, if there's one. We could also look at them and say, hey, there's infinite solutions, only one solution, no solutions because they're parallel. They have the exact same slope, different b's or y-intercepts, right? Put those in quotations for us. And then upon visual inspection of these graphs, we can determine what is that point of intersection. That we have actually, it is two answers we're getting here. One represents the x variable, one represents the y. Okay. And if they ask, hey, which of the two solutions are larger? The x is larger because 4 is bigger than -3 over here. The 2 is larger. And we also know that if we have a system, even though they may not both be linear, it doesn't matter. Wherever they touch could be a solution to that system. Okay? This is an interesting lesson, guys. It's starting to open up our minds about that these particular types of questions we're working with are going to help us be able to get farther in math and better improve our skills and things like word problems and all kinds of stuff. All right. So get out there, get that homework done for us, and have a fantastic day.